Move on to our second presentation, and this time we have on board with us Dr. Dilshan Silva. He will be talking to us about testing the not so normal. Let me introduce Dr. Dilshan to you. He is a senior architect, data analytics and insights at Wiley Global Technologies. He is a researcher and an engineer with experience in the UK and Sri Lanka as well. Dilshan possesses an array of academic qualifications, including an MSc degree in Advanced Software Engineering from King's College London and a PhD in Computer Science at Imperial College London. Dilshan commenced his professional career as a software engineer at IFS back in 2004. He then moved to the UK, where he was employed at BAE Systems, or British Aerospace, as a senior software engineer and then as a product support manager. He's currently senior architect with a demonstrated history of working in the education management industry. And so with that introduction, ladies and gentlemen, I now present to you Dr. Dilshan Silva.
So can you see my screen now?
Yes, we can.
All right. Okay. Presenting it now. All right. So today's session is on testing the not so normal. So the goal here is about me kind of demystifying what machine learning data science is, and to kind of create that enthusiasm among the quality engineers on how they can contribute towards data science. So I believe that there's a big gap, and I've been a strong advocate, a supporter of converging quality engineering with data science. So for today's session, we only have 30 minutes, but trying to cover kind of a definition. So trying to give you all a definition of what data science is. So it's something that a lot of people do struggle. Sometimes I do struggle to explain what data science is, but the goal here is to start with that. Given a simple example of a machine learning algorithm, and most importantly, how testing happens in machine learning, and then move on to the next steps. So let me start off with by describing what data science is. So it's the broad study, the field of study that relates to the theories, the concepts, all of this. It's something like physics. It's something like chemistry. It's kind of the entire study of data preparation, data analytics, and data visualization. All of you are obviously familiar with this, but trying to give you a definition on this aspect. So data preparation clearly is the part where you would prepare the data so that analytics can be performed on any computation. And I will go into detail on data analytics. Data visualization is just, it's about displaying the data so that people can understand what you have computed, what you have gathered. So if I were to go into what data analytics, so a lot of text here in this slide, but the data analytics part in data science. So data analytics is a part of data science, which kind of defines the process that examines the data. So we have a lot of data. The whole idea is, you probably heard of predicting, making predictions. Artificial intelligence is able to make all these cool predictions. So data analytics is that part. So it's about examining the data and drawing conclusions. So one important thing that I have at the bottom of the slide is the distinction between business intelligence and data analytics. So if if this was a live audience, I would have pointed fingers and asked some of you, but unfortunately I can't do that here. But the distinction is kind of pretty clear. Business intelligence deals with kind of existing or past data, and it will show you patterns of any interesting patterns or information about the past data. Whereas data analytics analyzes past data and it tries to predict the future. Okay, so we talked about data science, and now we know what data analytics is. Let's go into data analytics a little bit, and you would kind of see what machine learning is. Okay. So machine learning is kind of the part where it's a kind of a subset of artificial intelligence. So artificial intelligence is the bigger circle. So you have machine learning, and for example, if you were to ask a question, what falls in this circle which doesn't belong to machine learning, things like rule engines. So machine learning especially deals with data. So he passed data, and then the aim there is to make predictions. And then you have things like deep learning, where you have multi-layered networks in order to make these kind of predictions. So, I mean, if you have any questions, please be free to interrupt me anytime. But importantly, how does it all, so we talked about data science, we talked about data analytics, how does it all fit together? So we have this big box here called data science. As I explained, so it's something similar to chemistry or biology. And in data science, we have something called data analytics. So that's where the computation happens. That's where all the cool stuff, the algorithms are in play. And you have machine learning in that. So this is kind of the bigger picture of data science. And keeping in mind, it's a branch of computer science itself, data science. So I hope this definition helped you kind of understand some of the things that would have been unclear before. And a quick look into, it won't be complete unless I kind of talk about a couple of examples, applications of machine learning itself. Is Yelp is one of the applications on the left side. It's something somewhat similar to the Yahoo website that we have, but it's a little bit more, somewhat more intelligent, where people can provide provide their feedback on certain restaurants, where you upload images, and the system is able to, using AI, detect which category this image belongs to. For example, whether it's a part of a menu or whether it's a food item. And on my right-hand side, I have this example called Edge Case. Again, I don't believe you might be too familiar. It's not available in Sri Lanka, but it's an online personal shopper which analyzes, which takes into account your complexion, your features, and it gives you ideas on what clothing items would fit you most. So it's like a cool online shopping assistant, more or less. So future of data science. I mean, I can't call this the future of data science, but it's more or less the current applications. That's why I cut it off. So self-driven cars, smart cities, and robotics, again, use a lot of AI to function. And these applications, these things are in use in most of the developed countries, and in Sri Lanka very soon. So, so I kind of went through the definitions of data science. I spoke about a few examples. I would like to go through a simple example of a machine learning algorithm. It's called the decision trees. So decision trees, I'm sure all of you would have used this either as a kid or during your primary education, use this not knowing that it's a machine learning algorithm itself. So it's a very simple algorithm that uses existing data in order to make a prediction of unknown records. So kind of a yes/no scenario as well. I'll use a simple example, a kind of apt example here. Hope that all of you are kind of at least familiar with these superheroes. So I'm using the decision tree in order to predict. So look at the data set here, the training data set. You have these characters, fictional characters like Batman, Robin, and so on. So I use these set of features, and the goal here is I'm using the decision tree in order to predict if a particular character is either a hero or a villain. Okay, so that's the idea of this example. I'm using these features to make a prediction. So what I'm going to do is I'm going to create a decision tree from this training data set and make a prediction for any future character, so fictional characters. So so this is the training data set. So I will show you the decision tree that I created. It's a very simple one, and you can kind of apply these examples or these records and see whether it works on the training data itself. So if you take Batman, whether that character has a tie, yes or no, whether that character has a cape, yes or no, you can decide whether the individual is a villain or a hero. So in this case, you can see, you can try it out and see whether it works. So it does a good job on the training data, which is kind of normal. I mean, you created the tree using training data, and it should really work. So let's try this out on some testing data. So I didn't have these two records before. Okay, so ideally this decision tree should work and correctly categorize. So you have bad girl and the Riddler. And do apologize if you might not be familiar with these examples, but I believe most Sri Lankans are. So so bad girl ideally is a hero, and Riddler on the contrary is not. So if you use this decision tree, I start with the tie. So bad girl does not have a tie and has a cape. Yes, so you categorize bad girl correctly. This decision tree correctly identifies bad girl as a hero, and the Riddler is a villain, and it correctly identifies the Riddler as a villain. So it's pretty straightforward. You've done this. So the important thing is things can get more complicated. This decision tree is something that I created, but you could end up creating a decision tree like this. Okay, so the interesting thing, I don't believe when we were kids, when we created decision trees, we were familiar with things like overfitting. So overfitting is something, is a deficiency or a problem or a challenge in decision trees. In this case, if you look at this decision tree and apply these two records, the unknown records, you would see that it will predict bad girl correctly, which is good, but it will predict Riddler as a hero, which is wrong. So this is called overfitting. What overfitting is, when a decision tree works well with training data, but not so well with test data. So that's a problem that decision trees have. So on the other hand, we have overfitting, we have something called underfitting. So underfitting is when the decision tree is very general, where it doesn't work even, it doesn't work with the test data, and it doesn't even work well with the training data. So people who are not too familiar with machine learning, who are kind of very new to this, I mean, if you are confused, you don't need to worry too much, but it's about, I mean, all these things you can self-learn, all these things you can read and understand, but the important thing here is that these are all very basic things that you can learn, and machine learning is not something that is too difficult in certain cases to understand. So for completeness, now I showed you what a simple algorithm looks like, and I also showed you how the problems of the algorithm. What I'll show you now is another algorithm, okay, called random forest, that overcomes this thing, the problems of overfitting and underfitting. So random forest, just to summarize, I'm not going to go into detail. It uses something called bootstrap aggregation. Again, don't worry, people who are not too familiar with bootstrap aggregation, is a sampling technique. Okay? So imagine you have a large data set. Just look at the data set here. This data set here, there's only 6 records. You have millions of records. Imagine that's the nature of machine learning. We would need a lot of records to do accurate predictions. So if you have a large data set, what random forest does is, as the name implies, instead of having just one tree, you would have a set of trees, a large number of trees. And what we do is we break the data into chunks and we create independent trees like this image here. And that's called the bootstrapping, or the sampling part. You do sampling by replacement, and then you would aggregate the outcome where every tree would have a vote saying, so let's just example, you apply Batgirl to each of these trees and see whether the tree would say Batgirl would predict Batgirl as a villain or a superhero, and you just get the aggregation or the outcome of all these trees. So it's proven that random forest can overcome the problems of decision trees, which is overfitting and underfitting, and it's a widely used machine learning technique for classification. Okay, so and moving on to testing. So what is the goal of testing in machine learning? So quality assurance. I mean, being a software engineer and a data scientist afterwards, we consider software quality assurance. It ensures that a software system work according to what's on the label, or according to the requirements or the non-functional requirements, etc. So testing can identify most defects in development. That's what we know and what we are used of. So in machine learning, as you would understand, as you would already know, it's a little bit different. It kind of plays around. It uses a lot of data, and it's about getting the accurate output, which I will talk about in a little while. But it's a little bit different, something that you would need to understand, and you would need that knowledge about these algorithms as well. So similar to the decision tree, random forest, etc. So how, the important $1 million question is how quality engineering can get involved in data science. That's a goal. So I've always been a supporter of this. So it's about testing your machine learning code. It's about testing the accuracy. So therefore, I came up with this kind of a classification here. So just pay a little bit of attention. I tried my best to categorize testing, the potential of testing in machine learning. So I break it into two parts. So in testing in machine learning, I talk about testing. I highlight the importance of testing the code itself and the accuracy of the algorithm as well. So when I talk about testing the code, it's about testing the algorithm itself. So the decision tree or random forest at the end would be a library, be a set of code. Okay, someone would write this code. Okay, so as quality engineers, there is a lot of avenue, a lot of potential for you to test the actual code itself. And the other part is testing the usage of the algorithm, which we will have a demo in a few minutes. So the usage of the algorithm, because you have the algorithm, you need to use it in your application. You need to use it in your domain. So if the bank wants to make a prediction of the number of customers or the customers who would leave the bank or be defaulted, you would need to use an algorithm like that. And my example, the superhero example, if you want to predict what superhero is, whether the character is a villain or a hero based on certain features, you would need to use an algorithm. So code is there, and you can, as quality engineers, test that bit as well. And the other part is the accuracy. So as I showed you, the algorithm can end up predicting it correctly, and there's in certain cases the algorithm can fail. So as quality engineers, there is a lot of involvement here. Especially we call these things hyperparameter testing. I will not go into detail because 30 minutes will definitely not be enough to talk about that. Things like hyperparameter testing, hyperparameter tuning, more or less, and testing to enhance the accuracy of the algorithm. So what I will do now is something interesting. I'll hand you over to one of a highly experienced quality engineer who would demonstrate how to test the usage of an algorithm. So Jali, over to you. All right, thank you.
Thank you, Dilshan. Yeah. So starting this.
Can you see share screen?
Yeah. I think you can see Excel sheet. So yeah, starting this session. So I will ask a question from you all. So so if you are imagine if you are assigned for a testing task of machine learning algorithm, how confident are you to take up this task? So feeling a bit nervous because you are not specialized in that subject, or do you feel that you need to shift your testing paradigm, that come up with a new test plan strategy that you have never experienced before? So those are some concerns that I have before. So for that, yeah. So moving on, I think so. I'm getting a bit come up with a very a simple example. So you can see here there are some Excel. There's an Excel data sheet. So the data that I have extracted from a census database, the people of living in the United States. So using that, so when you come to the problem is here that we need to determine or to predict a salary per annum given by age, education, occupation, and so and so. The prediction will be in two categories. That's two categories. two categorical outcome. One is less than or equal 50K, another one is greater than 50K in dollars. So when you go to the solution, so we do have a Python application. So in that Python application, we are creating a model using a random forest algorithm. So when you go to, you can see there's a function. So we are reading data set. That is the data set that I have shown to you. So reading the data set and using that data set, we are creating two separate data sets. One is for the trained data set, another one is for the test data set. As name implies, that the trained data set will be going to train a model. So test data would be the testing the trained model afterward. And for this function, we are defining some parameters to define the algorithm. So as number of trees and number of samples each tree, but don't get much detail into that because those are the parameters. So finally, so using that trained data set, we are creating a trained model. So, and after that, finally, we are getting a trained model. So our goal is to test this function. So if you go to our test classes, so we have come up with a couple of test classes to test whether we have used our algorithm correctly, usage of the algorithm actually. So if you go to the first test case, so here that we are checking that the given function has used right amount of data to train the data, to train a model. So if you go to back to the implementation code, you can see that we have used trained data and as well as a test data. And as a norm that we know that we need to use a larger data set for the trained data set to create a model. So in that test case here, so this is not a fixed amount, but we have used that we have assured that the given function use at least a minimum the 70% of data of the given sample to get a better prediction of the given model. So that is our first test case. So when you go to the second test case, so we are going to digging deeper into our trained model, a trained data set. So in that test case, we are checking that the given function uses that whether it use a balanced trained data set in order to get a trained model. So in here, so given on the prediction, on that trained model based on trained data, we are calculating, we are counting those two outcomes, the category that is the target outcomes. We are counting those outcomes, and then we check those outcomes are comparable. So in an ideal situation, actually, so when you come to less than or equal 50K, the count and also the greater than 50K count should be equal, but in the ideal situation, but it should be closer. But in our test case, we are checking that so difference between two counts should be lies within the 25%. Okay, so that is our second test case. So when you go to execution of the test cases, so so you can see the result here. So we got one test case failed, one test case passed. So when you go to the failed test case, that goes when we are checking the balance of the data. So you can see here. The one part of a target outcome which gives the count of 80%, and other outcome which gives 20%, which going to be the a drastic incompatible. So there's a big disparity there. So likewise, so we have come up with some test cases. So this is, as a tester, this is just an start, but we have a lot to contribute. So I think, yeah, over to you, Dilshan.
Yeah, thanks a lot. So I hope that was helpful. Okay, so it was all about testing the usage of the algorithm. So in the first scenario, it was checking whether the right enough training data was used. And the second test case went deep into the deep into the training data set, and it checked whether it was a balanced data set. Usually in machine learning, when you train something, when there's two outcomes, like in my example, whether the number of heroes versus the number of villains should ideally balance. It should be ideally around 50%, but it's something that needs to be checked. So so I'll move on to, now I'll go back to my tree, the classification that I showed you before. In this, I talked about the accuracy. So in order to check the accuracy of the algorithm, we have something called a confusion matrix. Okay, so don't get confused here, but it's just a simple matrix that calculates, says whether these are, whether that you predicted, whether it was a true value or a true positive or a true negative, or if it doesn't predict it properly, whether it will be a false positive or a false negative. Again, I don't think I have, in the interest of time, to go into too much of detail, but these are metrics, similar metrics. So in using these values here, you are able to kind of calculate these metrics. Accuracy is ideally how well the algorithm performed. Things like sensitivity and specificity, the true positive rate, the true negative rate. All these metrics are similar to the metrics that quality engineering already has. So keeping in mind, these are very specific towards machine learning. So these are things that you need to learn. It's not difficult at all, but be aware. Okay, so in the case of testing my algorithm in the superhero algorithm, when I predicted let's assume that I predicted bad girl as a villain, so that will therefore my accuracy will go down. That will be a false negative. So it depends on the perspective. You kind of need to understand the context and what is predicted. So yeah, so that kind of covers evaluating, and that would be this bit here. So and finally, I'm running out of time as well. So points to ponder. What can you take from this presentation is that there's a lot of scope for quality engineers to contribute. So you need something that you need to understand is there's a lot of areas that QE can contribute towards data science, as you show in this very short presentation. And then more or less, let me rephrase it. So there's a lot of areas that data science can benefit from quality engineering. So that's a very important thing that I've always believed in. So and also I think data science sometimes can suffer because quality engineering is not applied. A few other things to note is that there are things like, I'm not sure how many of you are familiar with, there are tools like testcraft, retest, etc., that use machine learning for automated testing. You might already use that. It uses prehistorical data in order to automatically do certain tests, UI testing, for example. And the other part is that quality engineering can have a major impact on data preparation itself. Even in the data set that Jali presented, there are some problems, there are certain missing data. So things like minority sampling, there's a lot of things that are similar to what quality engineers do. So data preparation is one part. And then most importantly is the mindset. So that's something I always had a strong belief of, is the QE mindset is needed in order to make the whole process, entire data science, even better. So that kind of sums up what I wanted to say. So ending with this slide, but I think I'm right on time. Let me check. Am I right on time or?
Yes, we do have a few minutes for questions, and I
yes,
see we have 3 questions.
I'm very happy. Yes, right? I'll try my best. Yeah.
Okay. So, so perhaps we'll start with Nuwan's question there, where he asks, is there any specific tool for testing machine learning or data analysis projects?
All right. So, I mean, it depends on the language where what the machine learning code or the usage is written. So, if you use Python, you can write test cases in Python itself. On the very last slide, so if I try to kind of elaborate a bit, there are test tools that is created using machine learning. Things like pretest, for example, that uses machine learning in order to automate certain aspects of testing. So I hope I answered that question.
Yes. Perhaps you might like to stop sharing your screen now first. All right.
All right. Yes. All right.
Okay.
Stop sharing my screen. Yeah.
We have another question coming in from Darshana where he says, are there any UI automation tools operate with computer vision?
UI tools, I believe these are the ones that I just mentioned on my last slide. So yes, so quite a few tools are there for UI testing. It's automated. It uses historical data, things like testcraft, retest, test AI, for example. They use machine learning in order to order for UI testing.
And the final question here, with your experience, can you share recommended disciplines required to have unbiased imputation techniques in real-world challenges of handling incomplete data set without deviating from business objectives?
Yeah, for incomplete data sets, yes, that's something which is a major challenge. So when you have incomplete data sets, you would end up simulating the data. So if you don't have a balanced data set, you would need to have that balance for the machine learning technique or the algorithm to make predictions. So you have things like smart analysis or synthetic minority oversampling techniques in order to work on this. So it's another interesting area if I would move on to quality engineering, it's an area that quality engineering can really exploit here. So, there are various techniques, even in the minority oversampling techniques. You have things like k-means machine learning algorithms, so you could predict certain missing data. So these are the strategies that we follow, but there are so many others that that's proven and can be used.
Right. I suppose that's all the time we have for right now. Do you have any closing remarks that you'd like to share?
I'm very excited to be here, and thanks for the opportunity. So I hope I kind of enticed our quality engineers. I believe that's the bigger crowd in the audience. So yeah, so excited to see how this helped. And if you have any feedback or anything, you can be in touch.
All right. Thank you so much, Dr. Dilshan, for joining us, and we appreciate your time. Thanks.
Thank you. Bye-bye.